Okay, everybody. So Ellie had some questions on these derivatives, and I'm just going to roll through them real quick. So only goal is to find y prime. This involves using the trigonometry that we went over and a mix of the chain rule and the product rule. Don't think we have to use the quotient rule, not if you remember the shortcuts for the various trigonometric functions we're looking at. So looking at number 45 here, if y equals cosine 4x, I like using the parentheses to remind myself which one's the inside function and which one's the outside function. And then I'm going to find dy over dx, which I could also call y prime or even f prime of x. All these notations mean the same thing. And as I mentioned in class, first I'm going to do something. And that something is take the derivative of the outside function. And as we went over, the derivative of cosine is negative sine. Then I'm going to do nothing. The inside function never changes. And then I'm going to do something again, multiply times the derivative of the inside function, and the derivative of 4x is 4. So my final answer for y prime would be negative 4 sine 4x. Okay? Hopefully that was fairly straightforward. Let's go on to the next one, which would be something like, probably should have made 4 copies of the slide to begin with, but I didn't. So, 47, 5 tangent 3x. G of x is 5 times the tangent, which is our outside function, of 3x, which is our inside function. Now in taking the derivative, which since they gave us function notation, I'll be consistent and call g prime. Whenever we take any derivative, coefficients come along for the ride. The derivative of tangent, we said, was secant squared. So that's me doing something, deriving the outside function. The inside function never changes. And then we multiply times the derivative of the inside function, and the derivative of 3x is just 3. So g prime of x is 15, grouping together my constant factors, secant squared of 3x. And that's it. That's all we have to do. That's where we stop. So now, let's see. And now let's see if I can get PowerPoint to behave the way I want it to. Okay. And could have just erased it and redone it, but still. Okay. Now, for 49, y equals the sine, and I'm going to put a bracket here for a reason, of pi times x squared. When you see the exponent out here, what's being squared is the inside function. How do I know this? Because if they wanted to square the sine, they would have used the notation y equals sine squared of x. It's not my favorite notation in the world. For one thing, when it's a -1, it means inverse, not exponent. So, but still, the reason for it is if the exponent is here, the sine is being raised to the power. If the exponent's out here, just the inside function is being raised to the power. Parentheses and brackets to emphasize these things are often your best friend. So what we're going to do now in finding y prime is we are going to, once again, do something, derive sine, which we know is cosine, then do nothing because the inside function never changes. Now we have to multiply times the derivative of the inside function, and I'm going to use a bracket again, or maybe just a big parentheses, I think, actually. Now, in taking this derivative, okay, I have a second inside function. I'm going to bring down the 2, but inside these parentheses, is pi times x, which is yet another inside function, and it has a derivative. Now, things like pi and e, they tend to confuse kids, make you panic a little bit, but the fact is pi is just a number. There's no difference here than if it were 5 times x. And if my inside function, my second inside function in this case, but if the inside function is 5 times x, the derivative of that function would just be 5. Any number times a variable, the derivative of the whole expression is just the number. So the derivative of this inside function, my second inside function, is just pi. So when you have multiple inside functions, you have multiple uses of the chain rule, and the final form of this derivative is 2 pi squared x cosine pi of x squared. So we did something, we did nothing, then we did something, taking the derivative of the inside function, then the cycle repeated itself. We did nothing to this inside function, but we took its derivative and multiplied the whole thing by the derivative of the second inside function at the end. So this whole bit is the derivative of pi x squared, but then we have to apply the chain rule again, and the derivative of pi x is pi. Hope that was clear. If not, we'll go over it in class. But yes, when you have multiple embedded inside functions, the chain rule works multiple times. Now this last one requires us to mix and match the chain rule with something else we went over, the quotient rule. And not the quotient rule. By quotient rule, I meant product rule. So let's try that again. H of x is a product of two other functions. Sine of 2x times cosine of 2x. We can think of this as u times v. And then when we take the derivative of something with a product, the pattern is u prime v plus uv prime, also known as the product rule, but this is going to get a little bit tricky, and I want to give myself plenty of room to write it clearly. So u prime is the derivative of sine 2x. And the derivative of sine 2x is cosine of 2x times 2. That whole thing there is my u prime. And then v is just cosine 2x. And then that's plus, bring down that v to be clear. Oh, that's not what I meant to do at all. Okay. Yes, you know what? I think I'm just going to rewrite the v. Okay. And then plus uv prime. Well, u is sine 2x. And then my v prime is the derivative of cosine 2x, which is negative sine 2x, chain rule applies, times 2. So when I simplify h prime of x, I get 2 cosine squared 2x minus 2 sine squared 2x, which is probably not the answer you'll see in the back of the book. Because if you factor out a 2, you might recognize that you've got cosine squared of something minus sine squared of something, and that's an identity. That is an identity. One of the trig identities that we went over was cosine squared theta minus sine squared theta, which is cosine of 2 theta. So if you have cosine squared of anything minus sine squared of the same thing, it's the same thing as saying the cosine of double whatever was the inside function inside both of these parentheses to begin with. So this becomes 2 times cosine 4x, because if you have cosine 2 theta, it's the same thing as cosine squared minus sine squared of just theta. So if you have cosine squared 2x minus sine squared 2x, it's the same thing as cosine of double 2x or 4x. This 2 just came along for the ride. Now, if you notice a trig identity at the end of a calculus problem involving a derivative or an antiderivative, that probably means you missed a trig identity at the very beginning. So another way this one could have been done is if we first get rid of all this extraneous stuff here. What if instead of going straight to u times v, we had noticed, remember this trig identity, the one that says sine 2 theta is 2 sine theta cosine theta, which can be rewritten as 1/2 sine 2 theta is 2 sine theta cosine theta. It doesn't matter what theta is. Theta can be 2x, theta can be anything, but if we have sine of something times cosine of something, oops, I meant to get rid of this 2 here, sorry. My step there was, let me go back a second just to be really clear, guys. Sine 2 theta is 2 sine single theta cosine single theta. Dividing both sides of this by 2 gives me sine theta times cosine theta equal to 1/2 sine 2 theta. Because I noticed here that I had the sine of something times the cosine of the same thing. That's all you need to say we're really looking at 1/2 sine 2 theta. So it's kind of a long way of saying what I can do is rewrite, not h prime of x, I'm not there yet, rewrite h of x as 1/2 sine 4x. Okay, so this 1/2 sine 4x is the exact same thing as sine 2x times cosine 2x. And what I've done is I've eliminated the need to use the product rule at all. Because now h prime of x is just, bring down the 1/2, it comes along for the ride. Sine derives to cosine. Inside function does not change. Multiply times the derivative of the inside function. Simplify, 4 times 1/2 is 2, cosine 4x. So if you notice the trig identity at the beginning to get, if you notice there's a trig identity at the beginning that gets rid of a product, then that also gets rid of the need to use the product rule. Still have to use the chain rule though. Otherwise, if you don't notice that, you should get the same answer in the end. But, a lot of you guys are going to be taking AP Calculus next year, so that means a lot of times on that exam, you'll get a derivative like this, and the final choice, the only correct choice, looks like this. So one way or another, you have to be able to match the calculus you do to the answers they offer. I think it's much less common for you to get this, and for the final answer to be written in a way that cannot be simplified or condensed with a trigonometric identity. So that's about it. That was a tricky one. And obviously I'll be thrilled if you guys just, this stage, be happy if you guys just remember to use the product rule and the chain rule as you went along, because that's the point of this lesson. But the trig identities and the prior math we've done never go away. Okay, I hope this was helpful. I will post these notes in the Google Drive for everybody, and I will see you all tomorrow.